All right, so in this video, we're going to talk about some key vocab and graph a couple examples. Really, these first couple sections are really important because they're going to last through all of Algebra 2. So the first definition is the definition of a function. It's a relationship among two variables. It has an input. So normally the way you see a function, especially in Algebra 1 and then even a little bit in geometry, was probably written something like this. 2x plus 3, where you input a value for x and output a value for y. So that's pretty basic. Parent functions are the specific type of functions we're going to talk about in this section. And it's basically the simplest of functions. It's really basic functions, and we're going to use those to kind of give us shortcuts on how to graph more complicated functions later on. But we'll talk about those in just a second. Function notation. So this is really important. It's just a different way to write functions that you may not be familiar with. But really, people tend to make these harder than they are. So when we write something in function notation, so for example, the function, if we wrote y equals 2x plus 3 in function notation, it's going to be the exact same way. 2x plus 3. But instead of setting it equal to y, we're going to set it equal to the function f. People get confused with that f and think it's another variable, but really, all it is the name of the function. I guess it is a variable technically, but a little different than the x and the y. It's important to know that f of x and y equals basically mean the same thing, just written slightly differently. Then finally, domain and range. This is actually, we're going to go into this further in a later video, but I want to introduce this now, just so you have some exposure to it before the next video. Domain is all the possible x values of a graph. If you think about x values go left and right. So it's how far left and right the graph goes. Range is all the possible y values. So since y values go up and down, the range is just basically how far north and south the graph goes. And we'll see all of these vocab words in context here with this first example. So the first parent function we're going to look at is the linear function. So of course, linear function, the description is kind of in the vocab word itself. The graph is a line. And then again, you'll notice right here for equation, I wrote it two different ways. F of x equals x or y equals x. Again, they both mean the same thing, but we're typically not going to use y equals x very often, although I do use it in this first example. So let's go down here and make our table. So you'll notice in this table, the values we've picked for x are -2 to +2. And I've added a little note here. The parent function x values will almost always be these numbers. You're going to see there's some exceptions, but most of the time, these are a pretty safe bet to use those x values. So we're going to substitute those values in for x in our input, and they're going to output a y value. So of course, if x equals -2, if we input that in the equation, so does y. And this one's pretty easy because since the equation is y equals x, the y coordinate is going to just equal whatever the x coordinate is. Now let's just go ahead and graph those points. So the point 0, 0, point 1, 1, 0.22. Make sure you get the points in the right spot. I know sometimes if you're using a stylus, it can be a little tricky to actually sketch the graph, but the points themselves need to be in the right spots. And then go ahead and sketch the line. I'm missing an arrow there. Of course, there should be arrows on both ends of that graph. So now we're going to do domain and range. Now remember, domain is how far left and right the graph goes. These are really simplistic definitions, but when it's a continuous graph with no breaks, they're useful. So this graph, how far left and right does it go? So if we watch the arrow, if we imagine this graph continually going this way, it is going up and it is also going to the right forever. So as far as domain is concerned, it's going to the right forever. As we move to the left, it's going down and to the left forever. So we're going to use something called interval notation, which is just a parenthesis. So since it's going left forever, the leftmost coordinate is negative infinity. So we put it on the left side. And since it's going right forever, we put positive infinity. And then we close our parenthesis. Again, that's something we'll talk more specifically about later on. Range is how far up and down the graph goes. In this case, the range is the exact same thing, because as we said, it's going down forever and it's going up forever. If it's a diagonal line, domain and range will always be all real numbers. And then the last type of function we're going to talk about is the constant function. This is just a horizontal line graph. And you see one more time I use the notation y equals 1. Remember, that can also be written as f of x equals 1. Same thing. So again, when we go down here and see the graph, we see it's f of x equals 1. And basically this means no matter what we input for x. So if we input -2 for x, this function is going to equal 1. If we input -1 for x, it's going to output 1. So the constant function is really easy to graph because the output y variable never changes. So there's the constant function. So finally, let's list the domain. Domain is how far left it goes. Well, as you can see, this graph is going left forever, and it's going right forever. So the domain is -infinity to positive infinity. The range, this graph is not going up or down at all. Remember, the range is the y values. So one y value is covered here, and that only y value that's covered is y equals 1. And the way we write that in interval notation, we actually use square brackets since it can actually equal this number. We go 1, 1, since it's the only y value. If you just wrote it as a single number, that would be accurate as well.